one of the things with milk, at least, is that it is a whole food. It has micronutrients, it has fat, carbohydrate, and the protein is a very high quality protein. And the way it's digested is a little bit different than whey protein, because it's a little bit more slowly digested because of the casein. So we're really interested to see, well, how does that support the recovery after exercise in children, which would inform this will ultimately lead to, increased growth as they age.
Hello everybody, this is the Dairy Digression Podcast. I am Dr. Matt Lucy and I will be your host. We're recording from the 2024 American Dairy Science Association Annual Meeting in West Palm Beach, Florida. This annual gathering advances scientific collaboration and learning and also reinforces our personal and professional ties in the dairy sciences. Hey, if you missed this meeting, no worries. There's a meeting next year. It's in Louisville, Kentucky, June 22nd to 25th. And you need to be there. Abstracts will be open in the fall. You need to submit an abstract, so start working hard right now. And keep an eye out for more special episodes coming from this year's meeting. Today, it is a tremendous pleasure to have Professor Daniel Moore with us, who's an Associate Professor of Muscle Physiology and Acting Associate Dean of Research with the Faculty of Muscle Physiology and Physical Education at the University of Toronto. His interests include skeletal muscle remodeling, protein metabolism, exercise and lack of exercise, I think that's what that is, growth and development, and sports nutrition. He is a very accomplished author, having, according to Scopus, 114 publications, nearly 9,000 citations, and a very impressive H-index of 46. I hope I got all that correct, and welcome, Daniel.
Thanks for having me. It was spot on.
Do you go by Dan or Daniel?
Dan's just fine.
Dan's fine. All right, cool. So where were you born?
I was born in Burlington, Ontario, which is in between, or just outside of Toronto, is probably the best way to describe it.
Okay, so is it a suburb of Toronto or a small town outside?
Everything's pretty much a suburb of Toronto now. They call it the Greater Toronto Area, and it spans from about Niagara Falls all the way up to Oshawa, Whitby. So yeah, we're about 45 minutes outside of Toronto, but it's contiguous with all the other cities in between.
Do you get into Toronto? Oh, you're at the University of Toronto,
yes.
So you live in Toronto now.
Actually, we still live outside of Toronto for family reasons. So I commute in by train every day, and it's a nice way to start the day on the nice quiet train ride.
Oh, fantastic. So there is a reasonably good train system around Toronto?
Not as good as Switzerland, where I used to live beforehand, but it's relatively predictable, which is good.
Dan used to live in Switzerland, and used to work for Nestlé?
I did, yes. I got an opportunity to work for their research center in Lausanne, Switzerland for 3 years. Fabulous experience.
And I think you probably like the outdoors and hiking and...
Yeah, and that's what it has. Canada has that as well. You just have to travel a little bit farther to find the mountains, whereas Switzerland, it's all right at your doorstep.
If we have time, we should just sort of dissect away. This is a little bit of a travel program as well. Okay. Number one area to go hiking in Switzerland.
I'm just going to say the Alps, because it spans a large area, so you could pick any route. And I think it's the country with the most natural trails anywhere in the world. You could hike the country just over mountains and by foot. Coming back to this, what's really interesting is the first time that I was ever woken up by cowbells in the city. And so they had very big dairy producers, and so all their cows are free range, and you hear them. That's how they manage the grass. You hear them walking through the city eating the grass, and then the next day they're gone to the next city. So really neat experience just to hear those very traditional Swiss cowbells.
And it's a beautiful country.
Beautiful.
And beautiful, absolutely beautiful. So you're kind of a muscle exercise phys kind of guy. Okay, like you woke up one day, hey, I don't know, you're a runner in high school. How did this come about?
I mean, I was always active growing up and involved in sports, and so I wasn't sure what I wanted to do. There was thoughts about medicine, physiotherapy, and I thought, well, I'll take this program called kinesiology.
Oh, here we go.
Here we go.
Spell that quick, you listeners, all right?
I won't even spell it.
Kinesiology. I got it. I said it once.
You did it, yeah. So it's basically the study of the human body and movement. So, motor control, respiratory physiology, endocrinology, and I really enjoyed it. So I used my upbringing in athletics to kind of segue into an interest in learning a little bit more about that physiology. And then I got really intrigued by muscle, and we'll talk about why I think it's so important in a minute, I'm sure, but it's kind of how I rolled into this career.
Yeah, muscle, you probably, maybe you did or didn't imagine, but I think as the human population ages, there's so much more interest in this topic, right? Healthy aging. And one element of that is healthy muscle.
Yeah, and I'm a bit biased. I'd say it's probably the most important element.
Yeah.
But muscle is not just for interacting with our environment. So obviously that's important as you age to maintain independence, have a good quality of life, be able to play with your grandchildren. But it's a very metabolic tissue. And so when we eat a meal, we'd like to have the sugar and the fat from that meal end up in the muscle and not being stored as tissue. So it's a great place to help us clear the sugar from our bloodstream. So it has relevance to metabolic diseases such as diabetes. It's the only place in our body where we can store amino acids, and we store them as these functional proteins. So during times of stress, such as when you're sick or ill and we need an immune response, we actually break down our muscle to provide those amino acid building blocks for the immune system. So it really has a huge impact on all-cause mortality, and certainly individuals who unfortunately may have to enter the hospital. If they have more muscle going in, they have a greater chance of coming back out and coming back out more quickly. So for the many reasons, we think that muscle is so very important as we age, but obviously across the lifespan as well.
It's a fascinating thing because we had an earlier podcast talking about calcium, and her comment was, you have to understand that bone is more than just a structural component of your body. It's the primary storage location for calcium.
Exactly.
And if it's not just bone. And then you bring up the point with muscle. There's more to muscle than bodybuilding, and what people typically think about. It's absolutely, and the comment you made about it's where we primarily store glucose, for example, and of course with the epidemic and diabetes. With the epidemic and diabetes, we think about this constantly. Would the average person even know where that glucose is supposed to go, right? They might not. They might not. And muscle, of course, is a big place that's deposited. I thought the McMaster University, where it looks like you did your graduate degrees there, and I thought that was interesting. I did not, we were talking earlier, it's in Hamilton, which is sort of west of Buffalo. So you did undergraduate and graduate degrees there? Or?
Yeah, and that kind of stems from my indecision of what I want to do with my life. And I did my kinesiology degree, and I had an opportunity in my fourth year to do an undergraduate research project.
Fantastic.
With my advisor, Dr. Stu Phillips, who's a giant in the field of exercise and nutrition. And I enjoyed it. And so I just kind of kept rolling it into the next degree. And next thing I know, I finished with a PhD. And it was really just me being driven by asking questions that no one knows the answers to. So I always say that, I tell my students and anyone who's willing to listen, I kind of fell into a career in academia, and it was just because I had that early exposure to research.
I think that's an excellent point, Dan, is that we have a lot of young people that listen to this podcast, and how important that undergraduate research experience is. My personal experience was I didn't know about science. I didn't know about scientists. I thought university was like high school. And I was getting ready to go, I had work study, and I was a freshman, and I was getting ready to go to the dining hall to wash dishes, and my advisor said, would you like to work in a laboratory? And I'm like, what's a lab? I was in plant pathology. I was an animal science major working in plant path, but it's interesting, isn't it?
It is, and I tell anyone, like all my students, if you're even the remote bit curious, try it. Because it's just as important finding out what you don't like as what you do like. And I tried it, and I loved it. So you're right. You just take that opportunity and give it a shot. And then that's great in all of life, but that's kind of how I ended up where I am today.
I don't know how many times I repeat the same thing over and over in these podcasts because I don't have that many brain cells. But anyways, you're so fortunate when you find something you love. You're so fortunate. And probably the hardest thing is, when you're advising undergraduates and they don't know what they like. But when you get in that groove, it is so nice.
It is, and I'm very fortunate. I do feel lucky. But I also try and stress to the students that just because you do research doesn't mean you have to end up doing it for your life. There's a lot of important transferable skills that you learn doing a research project. So, being goal-oriented, time management, critical analysis, being able to speak to people about your work, whether it's in a conference or the 3-minute elevator pitch.
Yeah.
I mean, those are things you need in anything you do. So I think those research opportunities are a great training tool as well. That supplement and I think augment what you do in a classroom. Really, it's the more important work that you're going to do, the real world learning.
So you've now at the University of Toronto, and you mentioned that you were with Nestlé in Switzerland for 3 years, and I assume after that position you moved to Toronto.
Correct. There was a small section in there where I worked at the University of Guelph, but I came back because I loved working for Nestlé. Industry was a very formidable time for me, training. Growing up in academia, at least sometimes you hear about the dark side in this industry. And so I was able to kind of step behind the curtain and realize, no, they're a partner in our development of knowledge. And I think for me, it was just that I really enjoyed the group I was with, the company I was working for, the projects I was doing, but I had other questions that I wanted to answer that Nestlé wasn't interested in. So that's why I came back to the University of Toronto. And I've been just, very lucky to be somewhere where there are lots of colleagues who share my enthusiasm for research and great students who are willing to support it and, really do the research, because I can't do it anymore. I talk about the ideas and get the money, and they're the ones on the ground doing it.
For our listeners, Nestlé isn't just chocolate bars, okay? It is one of the largest food companies globally. It's massive. It is massive.
It might be the largest now, but yes. And that was one thing too. I mean, I came out of exercise physiology, and I thought, well, what are they looking for from me? And so, muscle really muscle's important for across the health span, lifespan. And so while they had Power Bar at the time as their sports nutrition business, they have dairy across the spectrum. They have clinical nutrition, trying to find ways to improve older adults' independent living or ways to enhance recovery from surgery. So they do a lot of things, and it's really rooted in what's the best evidence. So it was really interesting to be able to work at an international research institute with over 300 scientists from more than 60 different nations, and it was, you go in as a specialist and you leave as a generalist, because there's just so much there that you can learn from.
I was lucky, we talk about this industry academia switch or moves between those two. And I also, in my career, was fortunate. In between my master's and my PhD, I spent a year at Ciba-Geigy and in Research Triangle Park, North Carolina, working in industry labs. And then for my postdoc, I work at Monsanto, which is now Bayer in St. Louis. You learn a lot when you're working for these big companies that are doing science.
Yes.
And it's fascinating.
Yes. And, not that you can't learn similar things in academia, but it was a different color on research for me, and really centered on, what's the benefit from the end user.
Right.
And so it really gets at this knowledge translation piece too. You're doing research that hopefully will end up in a solution that will help people's health and well-being. So
it was, you learn stuff. It's just a different world. You're trying to develop products, and and there's certain things you have to think about. And Monsanto, we were working on bovine growth hormone at the time, and I teach endocrinology. I just love teaching about bovine growth hormone, and with that experience in industry working on bovine growth hormone, because you can tell stories and it just blows the kids' minds, the way we would approach things.
Yeah.
The very first crystal structure for growth hormone on any species was porcine. And it was because my boss's boss was Cliff Bale, who's now deceased, but he was from Missouri, and his family was a pig farmer in Missouri. And we had the most advanced technology working on growth hormone of any species. This was early 1990s. This was before we even knew what the receptor looked like. And we needed to crystallize that structure. And from that original structure in porcine, as you know, once you have the first structure, then you just feed in the amino acids to predict all the other structures. And it's that kind of way we went at things.
Yeah.
It's like, no, we're going to solve this crystal structure.
Yes.
And we ain't going to do it with one technician.
Yeah, now you can do it with code and one
AI. Oh, it's so different
one
now.
Computer, but that was you were the forefront of science there. That's where it all starts.
It's really exciting.
Yeah.
And so to a certain extent, sometimes I feel bad because students don't know that with all so to appreciate, as you mentioned, the new models that allow you to predict protein structure from primary amino acid sequence, it gets published in Nature and the students are like, yeah, well, whatever, it makes sense, but they don't realize that it wasn't
how it always done.
It wasn't always that way. It's hard, okay?
Yes.
And so it's hard stuff. Hey, so you teach, it sounds like you're doing both research and some teaching at the University of Toronto?
Yeah, and that's one of the things that I really enjoy, and one of the things that our faculty supports is having people doing the research also teaching the next generation of students. So I teach 2 undergraduate and a graduate course, and the 2 undergraduate are the nutrition courses in our faculty. So we're mostly physical activity, from psychological to sociological to motor control. And so in the physiology, I do the research. So we really talk about how can nutrition support an active lifestyle. And then we can also, in my 4th year course, we dip more specifically into athletes and their quest for excellence, and how can nutrition ergogenic aids support that.
Wow, those must be fantastic courses. The students must really enjoy that.
I hope so. I mean, I don't always look at the teaching evaluations, but I do get feedback that they really enjoy it. And it helps that they're elective courses, so the students that are there, are choosing to be there. And I enjoy it because every year it's different. As you know, science changes, and we don't teach from a textbook. We teach from the current evidence. So there are fundamentals about nutrition that don't change, but there's always something new to bring into the course. Hopefully, some of the things that I learned in the conference today, the research that we're doing, ends up in the classroom tomorrow.
Yeah, that's fantastic. That must take a tremendous amount of time. Did you say 2 undergraduate classes and a graduate class?
Yes.
Ouch.
Yeah, that's fairly standard. But yeah, we find ways to make the research work in addition to the teaching.
I think that's just so important, when you have experts like Dan here and bringing those experts into the classroom and teaching the students, and this is a big thing we have at the university, at my university, University of Missouri. Well, should we just hire instructors to do that? They're just freshmen, and what difference does it make? And you can get an instructor who has enough information, and boy, I tell you, you get the experts in there. The kids really appreciate that, don't they?
I hope so. Yeah, and I always tell them that expertise is relative. So every year I have students ask excellent questions that I don't know the answer to. And I think it's also important for them to see that just because I'm up here talking about the research doesn't mean I know everything about the topic or the research out there. So it's humbling as well when they ask those questions that you don't know.
This is Dairy Digressions, so we typically digress. Okay, don't worry, we'll get to the science in a second. But okay, are we talking 18-year-olds?
They can be as young as 17 if they got a late birthday. Yes.
Oh my goodness.
Yes. I feel old.
What's the key to capturing their attention in your classes? What's the key thing? What can you tell our young people that want to someday do research and teaching?
You have to find a way to make the content relatable. They have to understand what's in it for me. And I think that's where I'm fortunate that nutrition can connect to everyone. Everyone eats.
Right.
A lot of the students are active. They have older adults in their family. So I already have a bit of a captive audience. But it's really trying to change the lens. Yes, we're talking about science and evidence, but what does it mean to you, and how can you apply it in your life? And I think we love talking about ourselves as a species and find ways to relate the stories, and that's what we talk about in classroom. They're just stories to students.
Right.
How do they relate to me?
Yeah, so this is one thing that's interesting in animal science. So I teach freshmen 5 weeks of dairy science, and we have within that 5 weeks we have 3 or 4 lectures on getting cows pregnant, because that's very important. You have to get a cow pregnant so she can have a calf and make milk. I'm teaching about cows, but I also sort of kind of inform them about the human reproductive cycles and human pregnancy, and that's how I try to get them to listen to my cow lectures, because when you start talking human reproduction, you can just see the pencils they're writing it all down, and they're really interested in that. What's going on inside my body,
right.
And they may never have been exposed to that. We think they've been exposed to that in high school, but maybe not, or maybe limited, or maybe their mother told them something, but they're super interested in. And then when you sort of say, well, this is how it works in the cow, this is how it works in the people. Oh, by the way, all the things we talk about the cow, a lot of the original work on, for example, ovarian development was done in people, and then they're really like, oh, so there's some, like an oocyte in a person is the same or not the same, but it's not completely different biology.
Yeah.
So it's like you said, if you can relate it to them, you get more uptake.
Yep. 100%.
So at the same time, you got this research lab, and that consists of like, what is your happy number of people and distribution of people in your laboratory?
Yeah, we kind of reached steady state, and we were anywhere between 8 to 12 trainees in the lab, and
Wow.
it might be right now. We've got 5 PhD, 2 masters, and 3 undergraduates, and that's kind of normally where it goes, plus or minus. And we're in between postdoctoral fellows, so yeah. So I think 8 to 12 was a nice steady state. It's we've got a lot of ideas, and we need. As I said, I don't get to do the research as much as the students, so we need people to do that. But I also can't make it so large that I dilute my influence on the lab and be able to interact with the students. So, we found that 8 to 12 was great for cross-fertilization on different projects. It's important to support both the senior trainees, like postdocs, to help them get to the next step, but also build that grassroots pipeline and have those undergraduates as well. And so I really try and make sure that there's a blend of research experiences across undergraduate, master's, PhD, and postdoc.
So you have sort of a structure to your laboratory. It's not a flat reporting type, or is it a flat sort of reporting structure?
It is actually. So I don't want to build the hierarchy. I want to provide the experiences to have an enriched lab. But we meet weekly as a group to talk about current projects, journal club. And I meet individually one-on-one with each student every 2 weeks. I was very fortunate growing up to have a very collegial lab, and everyone was on the same team. There were no divisions, and that's the biggest thing I'm looking for is how do you work with the team? Because I'm not always going to be accessible, so you have to be able to lean on your colleagues. And just like in the classroom, I now have all the answers. In research, I might not as well. So the students have to realize that sometimes they're where the solution comes from and not from me.
As I listen to you, Dan, I can sense that you have an excellent lab, an excellent team, just by the words you use and the way you sort of express those. Again, since we have a lot of younger listeners here, just when you're looking for graduate programs, have these same sort of conversations with the people you might go work with.
Yeah, 100%.
And have those conversations. What's the team? What's the reporting structure like? What are your expectations? If they use words that make you comfortable and give you confidence, then that's probably what you want to go to. What's the direction you want to go?
Exactly. And so any student that comes to me looking to do research with me, I meet with them, I answer the questions the best I can, and then I direct them to my grad students. And I say, you're welcome to ask them anything you want, and they know that they can respond honestly. And I don't want to and will never hear about anything, because I want them to be able to pull the curtain back and understand, because I think I manage a certain way, but it's the student's perception that matters, and they have to be able to tell you about what it's like working in the lab, working with the people, working with me. And I think it's important for them to have that honest dialogue with people who they'll be peers with. Getting in that environment, sometimes you just know as soon as you walk on campus, this is a place where I could see myself, and then speaking with the lab kind of validates that. Trust your gut.
It's really true. You need to have these conversations, and I tell these students, I said, if you go visit a lab and it seems weird, or if the PI seems weird, he or she is probably weird, okay? And you don't want to go there. And don't think it's just going to be better, or maybe the PI was having a bad day or something, or if you're visiting a lab and no one seems to be talking to one another.
We've probably all got horror stories, but I've heard of labs where the culture is competition. And you might have 2 students working on a similar project, and the advisor just wants to see which one gets it first. Some people thrive in environments like that. I just think it's very toxic. I think it's a team. You can't work in a silo. You can't do everything by yourself. You're going to need to rely on others, as they will also rely on you. That's the first thing I look for. People, are they good team players?
Before I forget to mention, Dan is at the University of Toronto. For you people that aren't, I know the University of Toronto because I teach endocrinology, and of course the original discovery of insulin was done by 2 individuals, Banting and Best, working in the laboratory of a guy named McLeod, I think. Banting was an MD. Best was a graduate student. And Banting and Best and McLeod got Nobel Prize for the discovery of insulin. And it is a tremendous story in science coming from the University of Toronto. And we were talking earlier, apparently some of those original buildings
still exists. Maybe not in their original form, but they're there.
Yeah.
And so it's a really neat every once in a while I'll cross campus and I'll pass by and I'll be overwhelmed with the history there and humbled that I'm even in the same institution as where insulin was discovered.
It's tremendous, and people may or may not understand, but at the time, type 2 diabetes, which is what we all talk about now, wasn't even on the map. And we're talking about type 1 diabetes, which is juvenile onset diabetes and destruction of beta cells, and you basically die at that time before their work. It was a death sentence for children.
Yep.
It's a great story. There's a great movie. I just have to mention it because I love it so much. Dan's going to watch it now. It's called The Quest. The Quest, and it's an old, I don't know, Canadian Historical Society movie. It's about 45 minutes long, and you got to be a little bit of an insulin geek to enjoy it, but it's great. Okay, it's got all the elements of it's probably produced in the 40s or something like that.
Yep.
And so Benting he actually died. He was flying planes, I guess. He was ferrying planes during World War II, and something happened. I don't know if it crashed or something, but he was ferrying planes and ended up dying in association with his work there. So
You know far more about the history of Banting than
yeah,
I do.
man, I love it. Man, I love that history. Just before we leave, so how's the funding situation in Canada? How in terms of research funding situation in Canada?
Yeah, it's probably similar to the States in that there's different opportunities out there. There's the governmental funding opportunities. They call them the Tri-Council. So Canadian Institute of Health Research, which funds health research, Natural Science and Engineering Research Council, which is more basic science research, discovery research, and there's the Social Sciences Humanities Research Council. And that's more about the social impact, research and funding for education. So we typically play in the NSERC and CIHR area, and it's competitive, and there's a process to obtaining that funding. But if one of the things I talk about with my students is that if you're academia, you are first a professional beggar, and second, you need to have resilience because you're going to get rejected, and so that's part of the process. And we've been fortunate enough to obtain some of that funding to support our own research. But then coming back to the point earlier, having the opportunity to work at Nestlé and realize that they're a partner in research, there's also opportunity to reach out to industry collaborators, and there's the government's trying to facilitate some of that research too. So you can match your funds if sometimes one-to-one with different industry government research collaborations. So those are kind of the two main areas, and then there's also graduate student funding, and there are programs that support graduates and postdoctoral fellows working in academia, but then also spending 50% of the time with an industry collaborator.
Oh,
so I
fantastic.
think that's a very valuable opportunity to develop a different skill set, a new network, and to decide whether or not, as I said before, pulling the curtain back to industry is really what you want to do. So it's probably similar to the U.S. in that you've got NIH and we've got the Tri-Council funding.
Some of you are probably wondering, why do we invite Dan here? Why are we? This guy is a muscle guy from.
Asking the same thing myself.
Yeah. I mean, I just love muscle. Okay, but we're invited Dan here because Dan's here to give an invited talk, and he's going to talk about muscle development in children, and he's going to talk about milk and as a food that might support that.
Yes.
And that's what so we are getting to the point where we're going to talk about milk as a food that supports muscle development. And this is Dairy Digressions. This is about science, and we're not selling milk, but we're talking about the importance of good nutrition in terms of muscle development. Full disclosure, you're not paid by any milk marketing board. You don't own a dairy farm, do you?
I don't.
Okay, unbiased opinion. Okay. So could you tell me, I think it's so fascinating. You work on muscle development in children.
Yeah, and so, one of the things, you're right, muscle is important. When we study in adults, we can sample muscle taking a muscle biopsy. Our research is invasive. We don't do that in children, and sometimes we're not interested because children are growing all over. So we use stable isotopes, so amino acids that have a carbon label that has an extra neutron, for example, that we can track where it goes in the body. So we can measure metabolism that would lead to growth. So if a child's building more protein at their whole body level and they're breaking down, then their period of small growth that over time we could capture. So we use tracers to study the metabolism that underpins growth. And we know that if children are active, they have a greater muscle development than children who aren't. So we study active children as well, or including exercise as the independent variable to see what happens to their metabolism. And so we're trying to understand how nutrition can support that growth at the whole body level, which will then also impact skeletal muscle. So we have to be careful about, we don't study muscle specifically, but muscle is a very important and large component to total lean body mass, which includes, bone and organs.
This is a fascinating area of study, particularly in children. So I imagine the Canadian government, as is the United States government, is concerned about inactivity in children, obesity in children, and basically you're trying to understand how do you support the development of muscle mass in a child.
Yeah, and the first thing you have to do is you have to get that child active. Nutrition supports the growth, doesn't necessarily drive it, but being active is really the best way that you can reduce body fat, but also increase muscle mass in children. Yeah, so we may know how to support that growth. The next phase is how do we bring the population around to doing what it is they would need to support that growth. And as you said, the biggest thing is just getting kids active.
How do you handle in your research? I mean, do you break it down pre-puberty, post-puberty, or how does you must have to, because those two phases in terms of muscle growth are they vastly different or not?
Yeah, no, they are, and that's a great question. So we don't do chronological age. So a 12-year-old boy may be more similar to a 10-year-old girl. And so we define age by biological age, and it's around this, what's called the peak height velocity. So that's a period in your life outside the first year where you're growing the most rapidly. And that can occur at different ages based on your sex and your genetics. And so we can look at a ratio of the sitting to standing height, and then it gives us an estimate of whether or not they're at their peak height velocity or a year beyond it or half a year before it.
Sitting versus standing height.
Yeah, because our limbs grow before our torso does. So children
I did not know this.
Yeah, children have a slightly larger leg to torso ratio, which you can measure based on the difference between standing and sitting height.
Oh my.
There's been a lot of research that's looked at, well, how does that correlate with the pubertal growth spurt? So when we do our research, we consider adolescence as a half a year before to a year after their predicted peak height velocity, because it's not going to be the same for everyone. People just might have longer limbs. But it gives us a roughly homogeneous bucket as to they're really accelerating their growth now. Not just a linear growth, but also muscle development in both males and females. And then when we say children, we actually go farther away. We say they have to be at least a year and a half before their peak height, because children are still growing. They're growing relatively linearly. There will be growth spurts throughout that, but if you year to year, it's kind of a slow, steady trajectory. So children before their peak height velocity are fairly similar, whether they're males or females. They start to diverge quite a bit during that peak height velocity, and obviously at the end in adulthood, the end in total muscle mass will be different between males and females. But whether you're young or old, if you're active, you have more of that muscle than someone who's inactive.
It's fascinating. So and I know you work on adults as well, and so we go through this period of basically muscle accretion, where your activity promotes that, and then as you age, you go through this period of muscle loss, and activity slows the loss of muscle as you age.
100%. So, we're going to be at our peak between 20 and 30 years of age.
Oh no!
The one thing about muscles is very plastic. So no matter how old you are, if you exercise, you can be better than your inactive self.
Okay.
So certainly we are going to lose muscle with age. It's inevitable for the most part. It accelerates maybe after 70, 75 years of age. But people who maintain an active lifestyle, and especially if you're able to incorporate resistance exercise or lifting weights as you age, that's the best way to hang on to adequate quantity and quality of muscle mass as we age.
It's absolutely true. So I do triathlons, okay? And so,
impressive.
Yeah, so I just love that stuff. And I have a saying, when you're young, you train to get faster. When you're old, you train not to get slower.
100%, because unfortunately times also increase as you get older.
And it's exactly what you say, right?
Yeah.
And again, I would just, okay, N equals 1. I got no degrees of freedom here, but one of the things I've noticed in my training is if I don't incorporate that a couple of lift days a week, you just lose so much muscle mass, regardless of your other training. You lose muscle mass.
Yep. And even just the act of lifting increases strength through the neural practicing of the lift. And so someone who's stronger can also do more at a lower metabolic cost than someone who's not. So it's not just all about big muscles, it's about muscles that function properly. And so if they're strong, either because they're larger or you have that neural practice, the neural connection, then you're going to be better off than if you weren't active.
This is my guy, okay? I got my exercise phys guy forever, all right? Hey, I wanted to talk to you. So we've been talking about muscle mass, and we're going to probably focus on children in this conversation, or young adults type of thing. But I know the reason they're at this meeting is going to kind of discuss milk. I don't know if I'm even going to use the right words. Milk is a protein source for, I think you're working on recovery after exercise. Or can you just explain? I know you've done some research on milk. You know, milk is just casein, I guess, or whey proteins and casein and amino acids, but there's something a little different about it, or?
So we're starting to see if it's a little different in children. Certainly in research with athletes, animal-based proteins typically have more essential amino acids. And sometimes what we see is that they have more leucine, which is a specific amino acid that's actually in and of itself is able to turn on the process of building muscle. So research in older adult or young adults have broken milk out into its components, you know, whey and casein. And we've done some of that research as well. And, you know, if you're trying to stimulate the recovery quickly after exercise, then things that are going to be digested and absorbed by the body quickly, have a high degree of essential amino acids or leucine, are going to be able to flip the switch, you know, fairly quickly. And that's why a lot of the research you see or supplements on the market include whey protein. But what we are now starting to look at is, well, let's stop this reductionist approach and take a wider lens and look at more complete proteins or whole foods. And we're seeing that, especially after exercise in adults, there's a lot that will support that muscle building. And it can be from plant-based. We've done research that showed that actually whole eggs are better than egg whites. You know, we evolved eating food, and I still default to, well, what are the foods that we can eat that will help support that recovery? And supplements may be, you know, convenient, but they're not necessary, and in some cases not superior. So one of the things with milk, at least, is that it is a whole food. It has micronutrients, it has fat, carbohydrate, and the protein is a very high quality protein. And the way it's digested is a little bit different than, you know, whey protein, because it's a little bit more slowly digested because of the casein. So we're really interested to see, well, how does that support the recovery after exercise in children, which would inform this will ultimately lead to, you know, increased growth as they age, and then comparing it to other non-dairy sources or dairy alternative sources, because we can't lose sight of the fact that, you know, people don't eat just dairy; they eat other foods for a variety of reasons. So we're just at we know a lot in adults, and we don't know a lot in children. So a lot of my research actually is trying to see, well, are children little adults, or are they different? And if they're different, does nutrition affect them differently than if you're adults?
You know, this is a theme that we talked to a few food scientists at this meeting, and this is kind of a theme that, you know, calcium supplements you get out of a bottle, that's calcium, and that's not necessarily exactly the same as the calcium. It's the same molecule, of course, but it's not necessarily delivered and used by the body in exactly the same manner, the stuff out of the bottle, as the calcium in milk, you know. And it was fascinating. We had a conversation yesterday. I said, well, is it just because the calcium in the supplement is not absorbed in the intestines? Says, no, it's absorbed fine. It's just something beyond that absorption phase, you know. And then you talk about this amino acid profile being it is a I think that's something that we're sort of losing with all the hype about plant-based alternatives and everything else, is that milk has an excellent amino acid profile for people, right? Is this correct or not?
If you compare it to, for example, the profile that you'd see in muscle, so the amino acids in milk versus amino acids in muscle, the ratios are very similar.
Is that right? Really?
Yeah, and so plant-based can still be high quality sources, but they may be relatively deficient in one or more essential amino acid.
Right.
You can pace that over by just combining complementary proteins, beans and legumes, for example. But milk seems to be fairly complete, and if you look at what milk for any species is for, it's for rapid growth of a baby. And so whether it's a calf or baby human, milk hasn't been engineered to support that growth. So I think there's some parallels to why milk matches fairly nicely with muscle the profiles, is because we need to grow that when we're young.
Does the Canadian government support this type of research, or are they interested in it, or are you funding this from I don't know, slush funds or whatever?
Yeah, so we've been fortunate to pair up with Dairy Management Incorporated for some of our work in children.
Okay.
Nestlé, as we were talking about, they do a lot of research, and they have a dairy component, so they've supported some of our research. And there's the Dairy Farmers of Canada, which also supports some of this type of research.
Yes.
The government would support it if it had an end goal. And for example, with Canadian Institute of Health Research, does it improve health outcomes? So you can include dairy as an intervention in a study like that, but it has to funnel towards, well, we think this dairy is important because it has a specific health function. So I'm not sure of the complete landscape in the US. There are opportunities to support dairy research in Canada, but it's not necessarily at the government level.
So I got to ask, I know you at least have one child, because you mentioned you had a child in Switzerland.
3, yes.
Yes, 3. So that must be a pain, all right, to have your dad be like this muscle guy, and so are you hardcore in their nutrition, or are you just like whatever?
No. I mean, luckily my daughters are very active, and that's the most important thing. And it doesn't have to be in sports. It can be playing, and so
yes.
As long as they're active, as long as they're eating in moderation, I don't bring my research home.
Okay, bring it home. Here, drink this, all right?
Yeah, no. Yeah. I mean, we like milk in our household, but it's not something that I'm forcing down their throat.
Dan, I just wanted to let you know that I don't think you probably publish in the Journal of Dairy Science or JDS Communications, but this is a topic that we're super interested in, and they might offer you an opportunity to write a review article or something like that. But anything on the food side that has to do with human health is just highly cited and super important. And so we have this rewards program where we reward authors in terms of they earn points towards future publications, and reward authors for reviews. And so anyways, maybe someday, I don't think you normally publish in there, but we are very, very interested. We have a pretty big food section, and anything to do bioactivity and human health is just crazy. The other thing I would just I forgot to mention, I was supposed to mention it earlier, is that one of the things I think that we need to do as dairy scientists is start studying muscle in cattle as it relates to the aging cow, because one of the major reasons cows leave dairies is because they basically have musculoskeletal issues, and they fall down, and they might break something when they fall down, And it's amazing. Nobody really asks questions about, okay, how do we maintain muscle mass in a dairy so she's strong and stay strong and live a long life, because everybody would like their cows to stay longer, but a lot of times, and it's interesting. I'd be curious. I would love to know more about muscle and dairy and how that changes.
Yeah, and we were speaking beforehand that you mentioned this as an issue, and I wasn't aware of it because I'm in humans, but I see some striking parallels when you tell me that a lot of these cattle are confined to small space or don't get the opportunity to move around as much as they should, and if we do that to humans, we know what the outcome is.
Right.
They're going to lose muscle, they become less functional, and they open their increased risk for fractures and hips. So. I would not be surprised if you could increase the opportunities for movement in these cattle if you're going to improve their longevity, because muscle's so important. And I won't. Here's a digression. I mean, one of the things that I'm really curious about is you have animals that hibernate, that are somehow able to, and a bear is a great example, hang on to as much muscle as they can over 6 months of basically complete sedentary living. So we're interested in studying, well, how is that possible, and how does it relate to humans? But cows, like humans, don't hibernate. So I really think that the biggest thing that you can do is to allow these cows to move as they age.
You mentioned the Swiss cows. I mean, I think they do a lot of hiking up and down mountainsides and
Yeah,
stuff
there's
like
not
that.
a lot of flat pastures.
And they must be quite strong. And I once put up a time budget for 24-hour time budget for a cow, and they're expected to be lying down majority of the day, okay? And then they eat and they lie down, they eat and they lay down, and then they go to the parlor. That's their exercise. They go to the milking parlor and come back and eat and lie down. And I put that time budget up in front of a bunch of dairy people, and I said, you know what, if you went to the doctor and told them this is what I do, they would say, no wonder you don't feel well. Okay, they would
wow.
yeah, you got to really
That's
move around.
shocking.
You got to move, and get them to get your steps in. And well, that's not even, I don't even know if that's accurate, but you got to move.
Yeah. I think even just, if you can, so in humans, people really fixate on daily steps. We've got an incredible amount of data suggesting, around 8,000 is where you reduce your risk for all-cause mortality. Why can't we put a pedometer of some sort on a cow and understand, is there a minimum number of steps a cow should be doing?
That's an excellent question, right? And I also think
it seems like low-hanging fruit, and maybe people are researching that elsewhere, but yeah.
I'll have to talk to the guys at Guelph about that. They'll
Yes.
probably, they'll be like, "You're crazy." Okay, where's he from? Toronto? Oh, yeah, we don't like them. All right,
Nah, it's okay.
It's okay.
Yeah. No one likes from Toronto.
It's an excellent point, and kind of try to how to kind of keep cows healthy, over time. We are going to have to wrap it up. Something came into my mind I wanted to ask you, and just exited immediately. Okay, welcome to old age, but exited immediately. But
I'm glad I'm not alone.
Yeah, but I think the conversation's been excellent. And what we've heard today, over these series of podcasts with food scientists, is like, consider getting back to a food as a whole. Consider that maybe the food as a whole has some value. And maybe consider that if you break down a food into its component parts, maybe that's not equivalent to the food as a whole.
Correct, yeah.
And there's things we have to understand. And some of these foods that are produced, in dairy, milk as an example, maybe we just need to be real respectful, but there might be more to it than just the amino acid, or maybe more to it than we think. Is that fair?
They've been engineered by evolution. There's a reason why they have the components that they do. So
it's fair, right? And let's not go against how many million years of evolution, right? So it's cool. It sounded like your career in science was always, you knew what you wanted to do, but did anybody ever tell you anything or give you some advice that you thought was really important at some pivotal point in your career, or in terms of you as a scientist?
Probably, but I probably forgot it or incorporated it unintentionally.
Subconsciously.
But I talk to friends who are doing some of their research, and really I'm driven by, is the research question interesting to me? Is it done of high quality? And if you can at least tick those boxes, someone's going to read it. It may not be everyone, but do what people will give you money to do, but do the research that you're most passionate about. And there'll be others who are also passionate about what you're doing.
Excellent point. And that reminded me what I forgot. And I would just want to compliment you that the idea of using a bear to understand how an inactive animal can hold on to muscle, that's interesting.
Bears, squirrels, they're allowed.
Squirrels do it too?
Oh yeah.
Little squirrels?
Yeah, little squirrels. Yeah, maybe they'll be smaller in the spring, but a lot of that's the fat that they lost over the winter. So I know that there are labs, muscle physiology labs, that are researching this, and I'm always tuned into what papers they're putting out because I'm fascinated by it.
And what would you do if you weren't a scientist?
I'd probably be building decks and fences. I love working with my hands.
Oh, fantastic.
And I tell the story with my undergrads, I didn't know what I wanted to do with my career, and it'd vacillate between, medicine, physiotherapy, and I enjoyed in the summers working and building decks and fences. I thought, well, if all else fails, I'll just go back and use these hands for what they're meant to, not typing emails, but swinging tools.
Okay, I don't think we've had anybody say that before on this podcast. I knew this would be a good podcast. Great recording. A little different than anything we've done before. We never had a mesobiologist on. The messages are excellent. This is one thing I'm trying to encourage people to think about. Think about translational science, okay? Think about how your work on milk, translates to human health, or your work on muscle translates back to cow health, and that's how we make progress. We try to understand areas of biology, the bear, for example, that maybe we never thought about before, but is excellent way to think about our science,
Yeah.
you know, and so I thought this was really great. And I want to just say thank you for taking the time, because I know you're a busy guy.
So I'm glad we're able to make it work this morning, but I'm going to go away and think about that muscle loss in cows, because I think that's fascinating.
It's fascinating. And
the parallels are uncanny, really.
Really. All right, everybody, that brings us to the end of this episode of Dairy Digressions. Don't forget, if you enjoy Dairy Digressions, please like and subscribe. And if you have feedback or suggestions for speakers, please tell us at adsa@adsa.org. This has been Matt Lucey, your host. Until next time, enjoy your science. Thank you, everybody.